In the opening stages of the Second World War, the Axis powers faced a crippling strategic paradox that would ultimately dictate the limits of their global ambitions. Although Nazi Germany, Fascist Italy, and the Empire of Japan had bound themselves together under the Tripartite Pact of September 1940, they remained geographically, industrially, and logistically isolated from one another by insurmountable distances of land and sea. This massive geographical separation meant that while the Allied powers could construct a unified, high-volume global supply pipeline stretching from the factories of North America across the Atlantic and Pacific to Great Britain and the Soviet Union, the Axis powers had to wage entirely separate, uncoordinated conflicts on opposite sides of the Earth. Historically, the early attempts by Germany and Japan to bridge this gap relied on surface blockade runners, highly disguised merchant vessels loaded with rubber, tin, and specialized machinery that attempted to slip past the Allied naval nets by taking long, circuitous routes through the South Atlantic and Indian Oceans. However, by late 1941, the rapid expansion of Allied naval dominance, coupled with the introduction of advanced radar technology on British cruiser patrols and the establishment of high-density maritime blockades, rendered surface blockade running a suicide mission. The sinking of numerous surface blockade runners, such as the German merchant ships Rio Grande and Elsa Esberger, forced the Axis commands to realize that the surface of the world's oceans had become an impenetrable Allied barrier. If any meaningful strategic exchange of raw materials and cutting-edge military technology was to occur between Berlin and Tokyo, it would have to take place beneath the waves. This critical logistical realization marked the birth of the Yanagi missions, a series of top-secret, high-risk cargo submarine voyages designed to establish a clandestine underwater pipeline across the vast, hostile expanses of the Atlantic and Indian Oceans, connecting the industrial heart of Nazi Germany with the resource-rich, high-tech starved territories of the Japanese Empire. The design and execution of the Yanagi missions represented one of the most daring, technically challenging underwater operations in the history of naval warfare. Rather than utilizing standard, medium-range attack submarines, the Imperial Japanese Navy committed its elite fleet of long-range cruiser submarines, primarily the massive I-15 class, which were among the largest and most advanced underwater vessels of the era. Submarines like the I-30, under the command of Commander Shinobu Endo, and the I-29, nicknamed the Cherry Blossom, were converted into specialized cargo transports, their torpedo rooms and crew quarters cramped with heavy boxes of raw materials, scientific instruments, and gold bullion. The transit of these steel giants required navigating over 12,000 miles of treacherous, Allied-dominated waters, starting from the Japanese-occupied naval base at Penang in Malaya, crossing the vast Indian Ocean, rounding the storm-tossed Cape of Good Hope, and sailing north through the Atlantic to the secure, concrete-reinforced German U-boat pens at Lorient, Brest, and Bordeaux in occupied France. Historically, the German Kriegsmarine reciprocated by sending its own specialized type IXD-1 and IXD-2 long-range submarines, alongside the Italian Royal Navy's Regia Marina, which established a dedicated cargo-carrying submarine unit at Bordeaux known as Batisum. Submarines such as the German U-180 and U-511, under the command of elite captains, were packed with heavy machine tool parts, advanced blueprints, and scientific personnel, embarking on the return journey back to Penang. These underwater runs, which took up to 4 months of continuous, grueling submerged travel through extreme temperature fluctuations and suffocating air conditions, became the ultimate test of human endurance and mechanical reliability, as crew members suffered from chronic oxygen deprivation, heat exhaustion, and skin rot, while their massive steel hulls slowly pushed through the depths to establish the only physical link between the two Axis powers. The physical cargoes exchanged through the Yanagi pipeline revealed the stark, asymmetric needs of the two Axis empires. Germany's industrial war machine, although highly advanced and capable of producing synthetic substitutes, was choked by acute shortages of critical natural resources that could not be synthesized in sufficient quantities. Natural rubber, which historically was essential for manufacturing high-speed aircraft tires, heavy-duty truck wheels, and self-sealing fuel tanks, was virtually non-existent in Central Europe. Tin, tungsten, molybdenum, and quinine, the latter being the only effective defense against malaria for troops fighting in the Mediterranean and southern fronts, were also in critically short supply. The Japanese submarines arriving in France were practically floating warehouses of these precious materials, carrying hundreds of tons of high-grade rubber packed into every conceivable empty space, alongside pure tin ingots, tungsten ores, and industrial opium for pharmaceutical use. In return, the Japanese Empire, which had conquered a vast, resource-rich territory in Southeast Asia but lacked the advanced machine tools, metallurgical knowledge, and electronics industry to wage a modern, high-tech war, demanded the crown jewels of German military research. The German cargoes shipped back to Japan comprised highly complex machine tool dies, precision optical glass for rangefinders and submarine periscopes, specialized steel alloy formulas, active radar sets, and the complete technical blueprints for cutting-edge weaponry. This included the entire design documentation and physical parts for the Messerschmitt Me-262 jet fighter, the Me-163 Comet rocket interceptor, and the acoustic-guided torpedoes that had devastated Allied convoys in the Atlantic. This clandestine, deep-sea trade created a fascinating, high-stakes trade loop where the raw wealth of the East was bartered directly for the advanced scientific genius of the West, with both sides hoping that these microscopic infusions of critical assets would keep their sputtering war machines from grinding to a terminal halt. Historically, the single greatest threat to the Yanagi exchange was not the brutal ocean weather or mechanical failure, but the invisible, all-seeing eye of Allied intelligence. Through the brilliant decryption efforts at Bletchley Park and Washington, D.C., the Allies had shattered both the German naval enigma and the Japanese diplomatic and naval codes, including the Magic and Purple systems. Consequently, almost every time a cargo submarine transmitted a radio signal to coordinate a mid-ocean rendezvous or report its arrival window, Allied codebreakers intercepted and read the message within hours. This intelligence allowed the Allies to deploy dedicated hunter-killer groups, centered around escort carriers like the USS Bogue, which utilized high-frequency direction finding, Huff-Duff, and radar-equipped patrol bombers to hunt down and sink the Axis submarines with terrifying precision. In our history, submarines like the I-29, the I-34, and the I-52 were systematically intercepted and destroyed in the Atlantic and Pacific, their precious cargoes and technical experts lost forever to the ocean floor. Under our counterfactual scenario, however, the Axis commands take drastic, highly effective counterintelligence measures to bypass this Allied shield. Recognizing that their radio transmissions are being compromised, Berlin and Tokyo establish a strict, absolute radio silence protocol for all Yanagi transits, completely eliminating the high-frequency radio signatures that historically gave away their positions to Huff-Duff tracking stations. To coordinate mid-ocean crossings and harbor approaches, they implement pre-scheduled, highly complex astronomical routing timetables, which are printed in physically secure, non-decryptable codebooks carried by hand on the initial voyages. Furthermore, the submarines are equipped with advanced, passive acoustic detectors and early-model German Metox radar warning receivers, allowing them to detect the electromagnetic emissions of Allied search planes long before the aircraft can pinpoint the submarines on their own screens. By diving deep and utilizing extreme temperature layers in the ocean to mask their acoustic signatures from Allied sonar, this silent, stealthy fleet successfully evades the Allied hunter-killer groups, turning the historical slaughter of the Yanagi submarines into a highly secure, uninterrupted underwater pipeline. The successful security of the Yanagi pipeline triggers a dramatic, highly visible technological transformation across both Axis empires by late 1943. In the Pacific, the rapid and safe arrival of complete, high-quality German blueprints and physical prototypes of the Junkers Jumo 004 and BMW 003 turbojet engines bypasses years of painful, expensive Japanese research and development. Armed with these precise metallurgical formulas and turbine designs, Japanese engineers under the Nakajima and Mitsubishi corporations quickly overcome the severe heat treatment failures that historically crippled their early jet attempts. By the summer of 1944, the Empire of Japan is able to mass-produce the Nakajima Kikka fighter and the Mitsubishi Shusui rocket interceptor, deploying them in highly coordinated, high-speed defensive screens that devastate the formations of American B-29 Super Fortress bombers, whose high-altitude raids are suddenly met with overwhelming, jet-powered interception. Simultaneously, the Japanese Army receives advanced German Würzburg and Freya radar sets, allowing them to establish an integrated, highly advanced early warning radar network across the home islands and Pacific outposts, neutralizing the historical advantage of American surprise carrier strikes. On the European continent, the continuous influx of hundreds of tons of high-grade natural rubber from Southeast Asia provides a vital, life-saving transfusion to the choking German logistics. German Wehrmacht trucks, aircraft, and armored divisions, which historically suffered from a terminal shortage of tires and rubber hoses that forced them to utilize brittle synthetic rubber or wood-rimmed wheels, are fully re-equipped with high-durability natural rubber tires. This massive influx of rubber, coupled with thousands of tons of high-grade tin and tungsten, dramatically improves the mobility and mechanical reliability of the Wehrmacht's motorized forces on the Eastern Front, keeping the Panzer divisions rolling through the brutal mud and snow of the Russian steppes. In the Mediterranean and Balkan theaters, the arrival of massive shipments of Japanese quinine allows the Wehrmacht to successfully combat the raging malaria epidemics that historically incapacitated entire field armies, keeping hundreds of thousands of veteran German soldiers in the front lines to mount a far more resilient, logistically secure defense against the advancing Western allies. Yet, despite the dazzling tactical successes and the spectacular technological innovations of this secure underwater pipeline, the Yanagi exchange ultimately ran headfirst into a harsh, unyielding mathematical wall that would expose the entire campaign as a magnificent industrial mirage. In the brutal logic of global industrial warfare, the ultimate arbiter of victory is not the sophistication of a weapon's design, but the sheer, overwhelming volume of physical tonnage that can be continuously delivered to the battlefronts. A single American Liberty ship, constructed in a matter of weeks by the high-velocity assembly lines of Henry Kaiser's shipyards, could carry over 10,000 tons of heavy war cargo, including tanks, locomotives, ammunition, and aviation fuel. Over the course of the war, the United States built more than 2,700 of these Liberty ships, continuously pouring tens of millions of tons of steel and supplies across the oceans to sustain the Allied war effort. In stark, devastating contrast, the massive Japanese I-class cargo submarines, despite being the steel leviathans of the underwater world, could carry a maximum of only 300 to 500 tons of cargo per voyage. To put this into perspective, matching the cargo capacity of just a single, standard Allied merchant convoy of 40 Liberty ships would require over 1,000 successful, uninterrupted submarine voyages, an absolute physical and mechanical impossibility for the overstretched shipyards and fuel reserves of the Axis powers. Furthermore, the 4-month transit time of a submarine voyage meant that the flow of materials was incredibly slow and highly fragile, as a single mechanical failure, a pocket of bad weather, or a minor local navigational error could freeze a massive percentage of the entire trans-oceanic pipeline for months. Even when advanced German jet designs reached Tokyo, Japan's primitive industrial factories, ravaged by critical steel shortages and a complete absence of specialized manufacturing equipment, simply lacked the raw capacity to mass-produce these high-tech systems at a scale that could influence the outcome of the war. In the end, the Yanagi exchange proved to be a brilliant engineering triumph that won spectacular battles on the map, but it remained a drop of water in an ocean of Allied industrial output, proving once and for all that in a total war of global logistics, a microscopic pipeline of stealthy submarines can never defeat the crushing, assembly line tide of an industrialized continent.